In this video, I'll demonstrate my image analysis program to find subset images and give you a high-level overview of the Python modules it uses. Then, in the follow-on videos, I'll discuss the concepts and dive into the code to explain exactly how it works. The code is actually fairly short. The whole program is less than 170 lines long, including whitespace, and more than half of that is related to creating and managing the user interface. When you open up the exercise files for this Python code clinic, and you go to the problem2 directory, you'll find a script in there called subimages.py. When you run the subimages script, it'll give you this simple GUI window. You can click on the Browse button to navigate to a directory containing the images that you want to search for subsets within. I'm going to select this image directory, and this image directory is pointing to a folder that I've included in the exercise files called images, just here adjacent to the subimages.py script. And if you open that, you'll see it has 11 different images. And you notice some of these are cropped versions of the others. We have some images which are similar, but are not cropped versions. And we also have some images that are cropped and flipped versions. So it gives us a variety of different permutations to search through. Once you've selected the directory of images, just click the button to find subset images. The program will cycle through and analyze every possible combination of pairs of images from the directory to find images which are subsets of other images. The status bar is updated to let you know which pair of images it just finished analyzing and how many more image pairs remain to be analyzed. The progress bar is also incremented to represent the percentage of the analysis task that has been completed. As subset images are found, the GUI will populate a table to list pairs of images and specify which is the original image and which is a subset of the original image. After the program has finished analyzing all possible image pairs, the status bar will display done and let you know how long it took to perform the entire job. I used quite a few Python modules in my solution to this challenge. It's a mix of standard modules and third-party packages. The modules that I used from the standard Python distribution include the OS module for access to the operating system to generate a list of images and their respective paths in the search directory. From the math module, I used the square root function when calculating the root mean square, or RMS value for the image histograms. The time module made it simple to record the elapsed time during the program execution. And I used the queue module to maintain a list of all the pairs of images to be analyzed. Finally, I used the tkinter package with the themed TTK module to build a customized graphical user interface. There were also several third-party Python packages that I used, including NumPy, which is a common package for scientific computing in Python. I used it to store and process the image data as two-dimensional arrays. To actually import the JPEG images into my Python program, I used the Pillow package, which is a fork of the Python imaging library. In addition to using Pillow to import images, I also used it to resize images, convert them to grayscale, and calculate image histograms. The last third-party tool I used is the scikit image toolkit, which extends the popular SciPy library to add image processing routines. In particular, I used the match template function from the scikit images subpackage for feature detection to provide fast, normalized cross-correlation processing. You can find all of the modules in the Python package index hosted at python.org. You can find installers for each of the packages from their respective project pages, or you can install them using a package manager such as pip. If you're using Windows, then another good resource for binary installers for third-party Python packages is the webpage hosted by Christoph Golke. In the next video, I'll go into detail about the process that I used to analyze images to find subsets. I'll discuss the series of steps I took to optimize my routine for performance to reduce analysis time while still remaining accurate. I'll also explain the concept behind operations like normalized cross-correlation used in the match template function. After that, I'll walk you through the code to demonstrate how I use the various Python modules and packages to implement my image analysis routine. Then, in the final video, I'll show you how I used the tkinter module to create the custom GUI. You'll learn the how and why I used a Python queue module to manage the processing image pairs, and how I generated the elements for the queue using functions from the OS module. As we go through the code, there are plenty of little Python nuggets scattered throughout, which I'll be sure to point out so you can add them to your bag of tricks.